Okay, so I'm going to talk you through this calculation. We're going to work out the half-life, the KE, rate constant for elimination. I'm going to calculate the concentration 24 hours after the dose was given, and also work out the time when the concentration will be 10% of its value at the beginning. So just a few basic ideas, basic things that you might want to know about a drug. So let's have a look at the question. So we've got a single 500 milligram intravenous dose. So D is 500 milligrams. Following plasma concentrations were measured, and here we've got time in hours and concentrations in micrograms per mil. So the first question first, just by looking at the figures in the table, estimate the half time. Well, if we look at 11 here, half of 11 is, 5.5. So we've gone from 1 down to 12. So that's taken us 11 hours to get from 11 to 5.5. So we think the half time is going to be about 11 hours. That's just by looking at the numbers in the table. Okay, so now we need to draw a graph of ln C versus T and calculate the KE and the T half, and then we can see how well that compares with our estimate. So now I need to take the natural log of the concentration, and I'm just getting my calculator out, and I'm going to do ln 11. So you may well want to do this with me. Just check that you're getting the same answers. So that is 2.4. Ln 10.7 is 2.37. Ln of 10.3 is 2.33. Ln of 9.7 is 2.27. Ln of 9.1 is 2.21. Ln of 7.1 is 1.96. Ln of 5.5 is 1.7. And ln of 4.3 is 1.46. Okay, so now I'm going to plot this. So I'm going to have ln C here and T down here. And time is going up to 16 hours. Oh gosh. Yeah, let's do it that way. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And that's hours. And here we've got ln C, so it's going from 2.4 down to 1.46. So if I go for 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Yeah, I'm gonna. So that's 1, 1.2, 1.4, 1.6, 1.8, 2, 2.2, 2.4. That's rubbish. I'm just going to undo that. And I'm going to go 1, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 7, and that's rubbish too. One point 2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, 2, 2.1, 2.2, 2.4, 2.5. Okay, so at 1 it was 2.4. At 1.5 it's 2.37. At 2 it was 2.33. At 3 it was 2.27. 4 it was 2.21. 8 it was 1.96. 0.96. 12 it was 1.7, and 16 it was 1.46. Okay, so we can see that that is indeed a straight line. Okay, so there's our straight line. So now we need the KE. So the KE is going to be the gradient of the line. So it's change in y divided by change in x. So I'm going to call that ln C naught is 2.5. So I'm going to take it from there down to my last point here, which was 16 and 1.46. So, and this one here is 0 and 2.5. So the change in y is 2.5, take away 1.46. Just choose any 2 points on the line. And 0 minus 16. So if I work that out on my calculator, 2.5 take away 1.46 is 1.04 divided by 16. And that is 0.065. And the time was in hours, so that means my KE is in hours to the minus 1. Right, so there's my KE is 0.065. The half-life is 0.693 divided by KE, which is 0.693 divided by 0.065 hours to the minus 1, which is 10.7 hours. So that's not too bad. So KE is 0.065 hours to the minus 1. T half is 10.7 hours, which is pretty close to 11 hours. Estimate the concentration at time 0. So I said ln C naught was 2.5, so that means C naught is e to the 2.5. So I have to anti-log that. So shift ln 2.5 is 12.2, and that will be 12.2 micrograms per mil, because that was the units that I started with. Okay, so now we want the concentration 24 hours after the dose was given. So when T is 24 hours, what is C? So C is C naught e to the minus KET. So we can substitute in our numbers. So C naught was 12.2, times e to the ke minus 0.065 hours to the minus 1 times 24 hours. Notice that I've got hours to the minus 1 and hours, so that's all okay. So I'm just putting that into my calculator. So shift ln minus 0.065 times 24 is, so that comes to 12.2 times 0.21, and that is 2.56, and the units will be the same as I've been using, so micrograms per mil. Don't forget to put the units in. So the concentration at 24 hours is there. And then at what time will the concentration be 10% of its value at time 0? Okay, well, let's put that in down here. So that was 4, this is 5, okay. So the concentration is 10% of its value. So C over C naught would be 0.1 or 10%, okay, or 10th. So 0.1 is equal to e to the minus KET. Okay, did you see where I got that from? I had C equals C naught e to the minus KET, and I said C is a 10th of C naught. So say C naught was 100, C would be 10. Okay, doesn't matter what values you choose, as long as it's a 10th of, and then that works out to be 0.1. Okay, so that's just a little digression. Okay, so now we've got t up on this, in this power. We want to take logs of both sides. So ln of 0.1 is ln of e to the minus KET, and the log is the power to which the base is raised. So ln of 0.1 is minus KET. So use my calculator to work out ln of 0.1, and I get minus 2.3. Okay, and then I've got minuses on both sides, so I can just multiply throughout by minus 1 and make them positive, and then divide both sides by KE. So that's going to cancel out there. So T is 2.3 divided by KE, and KE was 0.065 hours to the minus 1. So 2.3 divided by 0.065 comes to 35.4 hours. So it took 35.4 hours for the concentration to fall to 10% of its value at the beginning. Okay, so that's how you work through some of those sorts of calculations.